Alright, hey guys, we're back at it with section 4, area of regular polygons. I'm going to try to get through this quickly so you don't have to watch this video too long, but it's a little trickier than the other formulas we've been doing. Area of regular polygons. Remember that regular means all the sides are equal length and all the angles are equal in measure. In this polygon, the center is Q. This is the center of the circumscribed circle. Our radius is segment QG, which is not drawn, but we can add that. From Q to G is a radius. And this is the distance from the center to a vertex. This is one of the vertices of the polygon. The central angle, we'll go with angle QGM, or GQM. GQM. So G to Q to M is our central angle, and it is formed by two radii. And then now this next word you're going to hear me pronounce differently probably every other time I say it. Some people call it the apothem, and some people call it the apothem. I'm probably going to mix it up and screw it up, but we'll go with apothem. The apothem is Q to W, and this is the perpendicular distance from the center to a side. So it kind of was like when we inscribed polygons or triangles. Inscribed a circle in a triangle last chapter. We had to find that perpendicular distance. This is what the apothem is. It is the perpendicular distance to a side. All right, and all these terms we're going to end up using in our formulas as we get to the back side. Okay, the formula for the area of a regular polygon is half the product of the apothem and the perimeter. So formula for area of regular polygon is equal to 1/2 times the apothem times the perimeter. Okay. And if we go down here, we kind of look at a proof for the area of the regular polygon. What we have here is we can divide this regular hexagon into a bunch of congruent triangles. And you can see as you do this, we're going to get 6 of them, 6 triangles. And if we were to call each side S, so we have side S, and if we call that A for apothem, that perpendicular distance right here, actually let me change colors. This is A, the perpendicular distance. The area of one triangle, is equal to 1/2 times the base times the height. So this would be 1/2 S times A, because in this case S is the base along the bottom, and your height of that one triangle is A. So the area of one triangle is 1/2 S times A. So if we look at this polygon, we have 6 triangles, but if we had a regular octagon or a regular pentagon, we would get n number of triangles depending on how many sides there are. As many sides, that's how many triangles there are. So we would say the area of n triangles is equal to the area of one triangle, which is 1/2 times S times A, times the number of triangles, which is n. So like in this case, n is 6, so it would be area of one triangle times 6. So this ends up being 1/2 times the apothem, and then we have S times n. And if we took one side length, which is S, times the number of sides, it's going to be perimeter. So what we would do is we substitute P in for S times n. We're going to substitute that in. And this would create area of a regular polygon is equal to 1/2 times apothem times perimeter. The hardest part here is going to be finding the apothem, finding the side length. But this is the formula we plug that into. 1/2 AP. Right. We flip to the back side. For example 1, find the area and the perimeter of a regular hexagon with an apothem of 6 meters. So again, let's kind of sketch like we did on the front. Put your center there, and let's sketch all of these different radii. So we sketch all the radii. The apothem is 6 meters. So if we take different color, this is 6 meters. So if we're given that, we can use what we know about these triangles here. The side length right up here. In these triangles, it's a regular hexagon. So that means all the sides are equal. Right, and we have to find out how many degrees are each of these angles on the inside right here. So we want to find that out. All these central angles have to be equal. So all the way around this angle, and this angle, and this angle, they're all equal to each other. And there are 6 different angles in there, because there are 6 triangles. So we have 1, 2, 3, 4, 5, and then that last angle is 6. So all the way around this polygon is a full circle. Think of it as this is a full circle all the way around, from here all the way around. So if we have a full circle being 360, we can take 360 degrees and divide that by 6 angles. So each of these angles is 60 degrees. So like angle 1 is 60, angle 2 is 60, angle 3 is 60. And if all of those are 60, that means this angle, if I change colors again, this angle right here must be 30 degrees because it's half of 60. So right now we know the formula for a regular polygon. Area of a regular polygon is equal to 1/2 times the apothem times the perimeter. We know the apothem. We know what A equals. A equals 6. We have to find out what the perimeter is. Each of these triangles right here, that triangle becomes a 30, 60, 90 triangle. And remember from 30, 60, 90 triangles, the long leg equals the short leg times the square root of 3. So right here, this x value is the short leg. And right here is the long leg. So we know that 6 equals x times the square root of 3. If we want to solve for x, we have to divide by the square root of 3. So x equals 6 over square root of 3. And then let's simplify this radical. Multiply the top and the bottom by square root of 3. 6 root 3 over 3, which is 6 over 3 becomes 2. So x is 2 root 3. That's how big x was. If we go to the bottom right, that's how big this is. That is half of one side. So half of one side is 2 root 3. That means one side is equal to twice as big as 2 root 3. That means 2 times 2, we get 4. So the side, or S, is equal to 4 square root of 3. So we know what the side is. It's 4 square root of 3. So now we have to find the perimeter, because the perimeter is what we care about. So if we want to find perimeter, the perimeter is the number of sides. We have 6 sides. So it's 6 sides times 4 square root 3. So our perimeter ends up being 24 square root 3. So now that we know P and we know A, the area of this polygon is 1/2 times the apothem, which is 6, times the perimeter, which is 24 square root 3. 1/2 times 6 times 24 ends up being 72. So this area is 72 square root 3, and our label is meters squared. So our final area is 72 meters squared. We also found out that the perimeter is 24 square root 3 meters. Right, so these problems do require quite a bit of work. We have to find missing pieces. Like here we had to find the angle, use the angle to find the side, and then use the side to find the perimeter. And that's how these go. They kind of go step by step by step. All right, and then example 2. Same thing, find the area on the perimeter of a regular octagon with a side of 8 inches. So that means each side is 8, and again it's a regular polygon, so all the sides are 8. If we sketch this, if this is the center, they tell us that the apothem, this perpendicular distance, is 3. So we can put 3 right there. That perpendicular distance has to be 3 because that's what the apothem is. So area of regular polygon, if you recall, is equal to 1/2 times A times P. We know what A is. A is 3. We have to find P, the perimeter. P is equal to 8 times the number of sides. An octagon has 8 sides, so the perimeter is 8 times 8. If you go through and figure that out, 8 times 8, we will get 64. And again, this is in inches. So the perimeter is 64 inches. We found that. And then now we just have to substitute. The area is equal to 1/2 times 3 times 64. So the area is 1/2 of 3 times 64. We end up with 96 inches squared. Alright, and this is kind of the more basic one. I know we started with the harder one, example 1, and this is more basic. Alright, so this one, they give us a apothem, they give us a side length. If we go back to number 1, they gave us the apothem, we had to find the side length. And in the last one, the area of a regular pentagon inscribed in a circle has a radius of 8. So this one, they give us something different. This time we know what the radius is. So we sketch all the radii. all of these things are the same length. All of these radii are 8. Okay. Again, the area is 1/2 AP. So area of regular polygon is 1/2 times the apothem times the perimeter. And we don't know any of this. We have to use this radius to find that. So we can start with this, just like in the problem earlier. How big is one angle inside here? If you look, we have 5 angles. 1, 2, 3, 4, 5. 5 different angles. And together they're going to form a circle. So all these central angles add up to 360. And there's 5 of them. So if we do 360 divided by 5, that means this angle has got to be 72 degrees. That's how big that angle is. So if we were to sketch an apothem, which is the right angle, we can call this A, and we will call this segment down here X. So we have A and X. And if each angle is 72, that means this part is half of 72. Half of 72 is 36 degrees. So we have this right triangle with 36 degrees. We want to find out the apothem, which is our dashed line, and you want to find X, because that X value will help you find the perimeter. So over here, to find the apothem, let's show our work. We have a right triangle. In that right triangle, we have a 36 degree angle. If we take that 36 degree angle and we want to find A, we will use cosine. If we take cosine of 36, adjacent to that 36 degree angle is A, so it's adjacent over hypotenuse. The hypotenuse of that triangle is 8. And again, we're referring to this triangle right here. So the hypotenuse is 8, adjacent side is A, so we will do cosine. And if we were to solve this, we would get A equals 8 times cosine of 36 degrees. We do get a decimal. We should get roughly 6.47. That's how big the apothem is. 6.47. Okay, so trig does come up in this chapter quite a bit. We will also use that to find our side length. To find the side, which is going to help us find X, we will use the sine of 36, and that is equal to opposite over hypotenuse, so this is X over 8. So if we were to just show all the steps, which I skipped last time, and we multiply both sides by 8, we end up with X equals 8 times sine of 36. So X is equal to 8 times sine 36 is roughly 4.7. So that's what X is. And remember, X is only half of a side. So if we want to find the side length, the side is equal to 2 times that. So 2 times 4.7. And 2 times 4.7, we get the side length is 9.4. 9.4 centimeters. So we know what S is, and we know what the apothem is. Now we have to find perimeter. How many sides are in this shape? Oops. There. In this shape, we have 5 sides. So the perimeter is equal to 5 times 9.4. And the perimeter ends up being 47 centimeters. So we have P now. P is 47. We have A, it's 6.47. So we go back. The area of our regular polygon is equal to 1/2 times 6.47 times our perimeter, which was 47. On a room. One half times 6.47 times 47 ends up being 152.05, and this is centimeters squared. Right. Again, this is a very tricky one. This section has a lot going on, and it's much different than just our regular area formulas. If you have questions, we'll go through a bunch of these in class tomorrow.